Yeah, so welcome to Vex Iq Strategic Approach. For those of you who are new, I noticed we had a lot of new signups. So just to let you guys know, welcome to Vex Iq Strategic Approach. Yeah, so all the previous videos that we've had, the previous seminars are on the Nova Systemic YouTube channel. So to find that, you can go to youtube.com/user/systemic solutions, and that'll actually give you access to the lectures if you missed any of them. And I would heavily recommend you do go through them because a lot of the stuff that we're going to be going on kind of either builds upon that or uses what we previously have done as context. So would recommend. My name is Afnan, so I'm a senior at George Mason University. I study computer engineering. I've also been involved with Vex Robotics since about 2011, 2012. So a lot of experience in years under my belt. Also, Kai is with us. Hey, Kai, can you say hello?
Hey, my name is Kai. I've been teaching Vex IQ, coaching Vex IQ for 2 years. My team won the states for 2 years in a row, and I would love for them to win states and go to world.
Yeah, Kai is also our head referee at our state championship for IQ, so he's super knowledgeable when it comes to that. Myself personally, I am a head ref at our state championship at most of the robotics competitions we have in Northern Virginia, as well as #toughest tournament, the signature event at Night at the Museum, and one of the world's referees as well. So to provide some context, Nova Systemic is pretty cool. We do a lot of different things, and this is just one of the seminars we're doing. So STEMinars, you're part of one right now. We have a lot of them available online, everything from, how to use some different types of technologies like Inkscape to robotics, cybersecurity, all the cool, interesting STEM things. We also do summer camps, which are kind of like extensions of what we've done in these seminars. So, this year's summer camps are definitely going to be shifted a lot to the online content. So I would recommend, if you find this stuff interesting, we're going to be doing even more in depth, even more detail, a lot more interesting stuff on our summer camps. So definitely sign up for those. We host robotics competitions. So that's just another thing we do. Let's see, we do STEM. That's definitely our huge tagline. Anything STEM related or involved. And we definitely want to get you guys interested and you guys involved as well. So if you find something, anything on our site, anything interesting, you can, or any questions really, you can email systemic@nvcc.edu and get any sort of personal question you might have answered, whether that be, what summer camps are available to me, or, how much does it cost to do a summer camp, or what are the logistics and all that. So, if there are questions, go ahead and email them there. All right, so an overview of what we're going to be doing. So because there were a lot of new people signed up, I just want to go over this overview again. Our goals of doing this STEMinar is going to be learning how to break down Vex IQ games and how to break them down piece by piece, understanding the point values, understanding the strategy and all that. Learning how to form strategies is a big part of that. So a lot of kids will just say, I want to score a lot of points and I want to win. That's not really a strategy. That's what you want to have happen. A strategy is how you go about achieving the end result of winning or whatever it might be. We're going to be practicing critical thinking and being more prepared for our next season. So these specific online STEMinars are definitely here to help you learn the skills. We have a few STEMinars that are scheduled after the new Vex IQ game release, which is going to be this weekend. So, tune into that. We are going to be talking about it briefly for maybe 5 or 10 minutes in the session that follows that. But these STEMinars are not going to be solely to take apart the new game. That is actually shifted to a summer camp. So if you're interested in, getting more one-on-one or personalized help, tearing down the new game that's going to be released on Sunday, we would definitely recommend you sign up for those summer camps. Our approach is going to be breaking down one game per meeting, reading the rules, watching some gameplay, and understanding why some approaches are better than others. So if there are no questions on that, I'm going to go ahead and proceed. So our plan for today, we want to go over some basics of communication, being proactive, breaking down a game, and end with some discussion and Q&A. And our goal is to have this end at 5 p.m. Eastern Standard Time. So, that's definitely the goal. What we're going to do is, if it does go a little longer, we're going to push to about 4:15 if we have to, and see if we can get some Q&A out of that as well. So communication. What is communication? A lot of students have this thing in mind, if I just say words out loud, I'm communicating with people. And that's really not what communication is. It's not just talking, but it's a back and forth. It requires one person sending ideas, those ideas to be received, and then ideas being sent back. It's just regular, information transfer. And you can't just yell at people and say, blah, 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 here are my ideas. That's not communication. That's just talking at somebody. You're not talking with them. So communication is the sharing of ideas. We send something out and, someone receives it and they kind of process that internally and send something back. You have to use the mindset of I could be wrong when you communicate, because, I'll see kids who are forming strategies, and Kai, let me know if your teams, if you see the same things with your teams, but often people will come up with an idea that says, this is my idea. It is super wonderful, super awesome. They don't even consider, what are the holes in that idea. So we need to share them so we can consider that, right? Kai, what do you think?
So one of my idea on sharing ideas and stuff like that is, if you have a good idea, yes, you can talk about it, you can discuss about it, but one of the most important things, in my opinion, is to actually put that ideas into action and test it out. So you have a great idea for a lift, you have a great idea for a intake system and stuff like that, but if you cannot put that idea into practice, or when you do put that idea into practice and it doesn't turn out great, you got to change your idea. One of the more important things for me is to not tunnel vision into one idea. So a team often come up with one idea and they think that's the best idea that they can produce, and they spend the entire season just work on that single idea and try to improve it. But if you just tunnel vision on that one thing, you're going to have a lot of limitations on what you can and cannot do. But if you explore other options, so you have explore the ideas, or even, let's be honest, copying other people's idea, it might turn out better for you.
Yeah. So that's some great insight, Kai. Thank you. Yeah. So it's one of the most important aspects of Vex IQ, I think, because this whole game revolves around more than just one person, right? It is the key cause of frustration for a lot of teams. I've seen teams at the field like, oh my God, what are you doing? Why would you do that? You're messing up, or something. Or, just people who are just standing there at the field, staring at a wall while their partner is driving. They're trying to pass the controller off or something, It's a key cause of a lot of frustration, because often people don't think that someone else is listening to them, or, they're just ignoring them. But it's often because the communication is not going well, that there's some misalignment in what people are thinking. People could be on the different page. So remember, every match is played with another team, so you can't just kind of think about yourself. You definitely have to communicate with another team to make sure that whatever points you put up, you do so together, and that you both are on the same page and you don't run into each other. A lot of times if you look at a Vex IQ match, you can see kind of where the communication lacks by when those robots run into each other, right? If you're trying to go one way and some of the robots trying to go the other way, it should be very easy for you to tell them, hey, I'm going to go here. Could you move a little to the left? And they should be able to kind of respond as such. Anytime you've run into your alliance partner robot, you know that there was a lapse in communication. So, make sure that you understand one another and do a dry run to stay on the same page. Sometimes people will go up and say, hey, for this next match, I think this is what we should do. I think that we should pick up these points. We should kind of drive past each other and put them on. Or we should do this first and this second and this third, right? And you might think to yourself, well, yeah, as soon as I've told them what I want to do and what the plan is, that's information transferred. They understand. But sometimes you don't really get the same idea just by saying the words you thought gave somebody that idea, right? It's often beneficial to do a dry run and say, okay, let's practice what we just said we would do so that we can see what would come out, right? And then maybe in that practice, you see, oh, you thought I meant this. No, I meant this instead. Or, oh, I had this idea, but the way you did it works so much better. We can just do it this way. So that's a huge part of communication, is making sure you're all on the same page. I can't count the amount of times that I've given an idea out to one of my teammates and said, oh, what if we built something that works like this and does this? And someone goes, oh, I got it. And then, when we start building it, I'm so confused as to what they're doing. I'm like, what the heck are you doing? This doesn't look anything like what we explained. That means that I didn't do a good job, communicating those ideas. So that's a key cause of frustration, key cause of time loss. And you definitely want to make sure that you avoid that. You can save so much time by spending 5 extra minutes just talking to somebody. If I told you, I could save you a month. If I told you I could help you score 15 more points just by listening to what someone's saying for 5 minutes, you would do that, right? You have a whole season to do all this work and all this practice, and spending 5 of those minutes of this season, listening to somebody else's idea, or taking a moment to kind of make sure you're all on the same page. That could save you a lot of build time, a lot of programming time, and a lot of just confusion, right? Definitely try and take that 5 minutes when you have the opportunity to. Draw it out. When people are making designs, they, like I said, they'll describe the theory and they'll think it's the coolest thing they've ever thought of. But as soon as they put pencil to paper, they kind of forget what it looks like, or they don't fully understand what the idea is. Yeah. So that's pretty much, a good idea. Hey, Kai, what do you think about the communication?
So one of the more important things about communication, in my opinion, is if I was a coach, well, I am a coach. This is just a recommendation for other coaches out there. The first weeks, or maybe the first couple weeks, at the very beginning of every class, you got to go over the rules. A lot of students, and I mean a lot, I cannot stress this enough. A lot of students don't remember the whole rules, or they interpret the rules in the wrong way. And you often don't learn about it, that you've been doing the same thing over and over again that is wrong until you go to competition. And that is just a waste of time, because you might develop a great strategy, but it's not legal to use within competitions. And that would just waste a couple of weeks or even a couple months of your time. And time is very limited, because a season lasts, a year? And you only have about 9 months to actually build your robot, go to competition, try to make it to states, to worlds, or whatever you're going to do. And yeah, just stay on top of the rules, read the rule book throughout, make sure that your students actually understand it. They know what time to switch, they know how long they have to do each task and stuff like that. Just make sure the rules is very comprehensive before you start building, just to prevent wasting time later on in the future.
Yeah. And that's a huge point Kai brought up, right? Because like I can't count the number of times Kai has had to disqualify a team because the person didn't tell the other person that they needed to pass the controller. Like that's easy, like one sentence, and that would have let you put your points up. But yeah. So like Kai mentioned, when you have an idea or something, make sure you elaborate on that correctly. So here's like a quick, like what would be a good way to elaborate an idea, right? So someone comes up and says, hey, this is my idea. Or that is when you present the overview or the theory of the idea, right? You don't tell them how to build this. You don't tell them how it's going to work. You just present them the theory. What could this idea do? What is the purpose of this idea, right? Once you've said that what the idea is, you tell them, hey, these are the issues that this idea solves. I noticed that we're having a hard time with weight. I noticed that we're having a hard time getting the right size, the speed, or you can't pick up the game object, right? It's a really important thing that you set what issues it solves, because that directly identifies why you're doing this idea. The theory might be, if the tower for our lift is leaning forward, we need something to make it stronger. We need something to make it more sturdy. So that's the theory. That's the overview, right? Then you would say, okay, well, what issue does this solve? This solves the issue of we can't pick up the game object because our tower keeps falling off, right? So we've identified what the idea is. We've identified the issue it solves. And then we can say, okay, this is why I think it would be a good idea. This is where you would do the math or the examples. You could say that, adding some sort of support to prevent the tower from leaning forward would help us pick up the points. And picking up the points would mean we could score more of them, right? So now you're explaining why you think the idea is good. And then after that, you would say, okay, this is what it would look like. This is where you get into the implementation, right? So we want to make sure that we understand that an idea has multiple parts to it. There is the idea, just like the theory of what it does, and then how you're going to implement it. Those aren't the same thing, because you could say that you want to put a support on that robot, and that doesn't mean you have to do it a specific way. That just means you need to achieve a goal. You could achieve that goal in many different ways. So when you draw what it looks like, that's when you get an actual implementation or an actual idea of physically what it would look like. And that's the best way to kind of show someone, oh, well, this is exactly what I was thinking of. Once you've kind of said what you think it could look like, you ask, what do you guys think? You ask the team for feedback. Doing these steps and kind of isolating them in this fashion is great for communication, because everyone understands all kind of facets of the idea that you're putting forward. Additionally, it's great for documentation, right? You've now said, boom, this is the idea. This is what this idea fixed. This is why we needed the idea. This is how this idea would help us. This is what it would look like in drawing. And this is what the team said. That's a lot of the engineering process, is just, isolating the decisions you've made and then explaining why they're good. Because you guys have good ideas. Everyone has good ideas for their robot, but they don't know why they're good, right? Someone might say, well, we need to put another motor on base. Okay, well, why do we need to put a motor on the base? Having the students identify the fact that they've had a good idea, what led to this good idea? They can then isolate, oh, well, I just thought it was good because our robot's too heavy. Okay, well, now they recognize that the robot's too heavy. Maybe they can also make the decision to take some parts off. They recognize that motors, just having one or two motors isn't strong enough. Okay, so they identify that there are limits to the motor. Breaking down in this fashion is great for your documentation because you've now explained the decision and justified every part of it. It's not just a random decision you made. Being proactive. So, what does it mean to be proactive? A lot of people are just like, oh, I can do whatever I want to do. But proactivity is kind of always being in control, right? So proactivity is causing an outcome instead of making a decision responsively. So you can either be proactive or reactive. Proactive being I've made a decision and that causes a result, or reactive being there is something that happened and I have to make a decision because of it. Although they're they sound kind of similar in the sense that, I'm going to make a decision regardless. The difference is when you make that decision and how in control you are. When you behave responsively, you don't really control the situation. You just have to do something to get out of the current situation you're in, right? If you're proactive, you are now always in control. And that's a huge thing there. It's super good because you maintain control at all times. You are at no point confused, lost, or just, spiraling. You know what you're doing and you maintain enough control, enough power to control your future. When you can control your future, you can control the points you put up, right? You can do better as a result. You can perform at higher levels. If you know that, this game is a pick up, put down game, or that, your next alliance partner is only a push bot. They can only put the points that are on the ground for the floor goals. That's fine because you proactively identified that. You can now go up to them before the match. You can talk to them and say, hey, we think the best strategy to use would be while we pick up these points, you actually push these points over here. You don't get to the field and go, oh no, we don't know what these guys can do. We're going to have to make something up on the fly. When you make things up on the fly, it's a lot harder to make them good decisions. It's a lot harder to think them through. But if you are proactive and you spend a few minutes before the match, before whatever, planning, you're going to end up performing a lot better because it's not just guesswork. This is a calculated decision you've made. You don't need to think on the fly. Yeah, thinking on the fly is a great skill to have. It helps you be, dynamic and flexible, but it doesn't always necessitate better results. And so if you have the time, you might as well spend the time so you can get better results. So, how do you be proactive? You make a game plan, whether it be your build season, your competition, or, just the session. You make a plan for it. You could say that, for this next meeting, I want to achieve this. And if I achieve this, I will be happy. That prevents you from just showing up to a build meeting and saying, oh, what are we doing today? Is it snack time yet? Can I leave? Are we done? Having definitive goals, makes it very possible for you to work towards those goals. Because if you don't know what you're working towards, you're kind of just doing work and seeing what will come out as a result. You don't really have a plan for it. You're just doing stuff. Make a plan B and a worst case scenario plan. If your plan A is we're going to score all the points in this fashion, have a plan B. Say that, maybe if one thing doesn't go right in that plan, this is what we'll do instead. If our alliance partner is not the right one that we need, then we'll go to plan B and we can still put up some points. You're still calculated, right? But the worst case scenario plan you want to have for if everything goes wrong. If everything goes wrong, you still want to have a decision to make, right? So that when you're doing whatever it is you're doing, you can say, okay, something went wrong. We need to go to plan B. Or, oh no, everything is going wrong. Quick, go to the worst case scenario plan. That's a thing you knew what to do. You didn't have to make that plan up on the spot, right? It was calculated. It was predetermined. Now you know what you're doing before it becomes a problem and you need to make that up. And, determine what does it take to achieve that game plan? Because if you've made a plan, that's fine. Those are your end results. Everything in between is the process that you're going to define. So determining, what does it take to achieve that game plan is kind of the big part of that. It's more to just say our game plan is to win. Our game plan is to score the most points. Our game plan is to score the points here, here, and here. It's very important to say, well, how do we do that? Because you now have isolated the individual steps you need to take to do what you want to do. Do you have any questions on that? Are we kind of all there? All right, cool. So like a season plan, what would be an example of being proactive on a season plan? We could say that, the first 2 or 3 weeks, game analysis, strategy. We just want to break down the game. We want to understand how the game plays. And we just want to, be in control of how we're playing the game. We could do 1 week of prototyping and watching videos. And after that, we'll do 1 week of designing, just kind of putting our ideas on paper, drawing what they should look like. Once we've done designing, we'll do 2 weeks of building, and we'll do 1 week of basic coding, just so we can get whatever we've built up and functional, right? And then we'll do a 1 week test session. That's where we'll get all the data of, how good does it do? How many points can we put up? Is it working the way we thought it would work? And then 1 week reflection to say, okay, well, that didn't work too well. Maybe we can do something else. So to be super successful today, we need to. These are like 2 examples of what it would mean to be proactive. For your season plan, I would definitely recommend you have those dates there, just because if you let them know that, hey, well, 3 weeks from now, you need to have your robot fully built, or 3 weeks from now, you need to be done with your basic coding. That lets your students, and that lets you as a person, kind of plan what you're going to do in between then. Because if you don't have these dates, you're just kind of aimlessly doing work until you think you're done. But once you give yourself that date, you now know that, hey, I need to be ready to have a robot built and driven by this date, right? You've now kind of set the big chunk times of when you want to have things done. And you can now say, okay, well, in those large chunks, how am I going to do that? I have 2 or 3 weeks to do game analysis and strategy. Okay, well, what am I going to do in those 2 or 3 weeks? Maybe week 1 will do this, and week 2 will do that, and week 3 will do that, right? So that's kind of a great way to line up what you want to do and be more prepared for the actual season. So you don't just get caught a week before states and you're like, oh, I don't know what to do. Do I have enough time? Do I not? Making these plans beforehand is the most advantageous way to use your time. And honestly, to be super successful today, we need to is a great question to ask yourself and ask your team, because I have the same thing a lot, where I show up to the meeting and I go, oh, so what are we doing today, guys? And they go, oh, we're just working on the robot. We're just going to keep progressing. And that's cool, because that's your goal. You want to keep progressing on the robot, but you need to know how you're going to do that. One sec. So, it's good to have the students kind of line that out, because one, they know that what do they need to get done today so they can feel good about themselves and feel that they definitely achieved what they wanted to achieve. And then, okay, well, maybe there's 5 things on that list. You want to have 5 things to be super successful. Okay, so maybe we didn't have a super productive day. Can we do at least 3 of those things? Can we at least, change the wheels so that they are not as slippery? Can we make the robot smaller so it's not out of size? And can we score at least 10 points by today? Having these definite goals saves a lot of time and prevents people from just aimlessly, doing work or kind of just floating in the clouds, so to speak. Kai, you got anything on that?
So one other thing that I normally do is, and I think it's very beneficial to incorporate into your planning, is to list out all the tasks within that game. So say, let's talk about last year's game, Swear Away. You have a couple of tasks. You have to move the green cube. You have to move the red cube. You have to stack the green cube into the higher or the lower towel. You can stack the balls on top of the cubes and stuff like that. If you list those tasks out and rank them into difficulty levels, so say the most difficult task would be to stack the balls on top of the cube, stuff like that. And the easiest task would be to just slide the red and the blue cube to the other side of the field. If you list those tasks out, if you list those tasks out and rank them by difficulties and build your robot accordingly, it makes it a lot more structural for your robot. Say, I'm going to dedicate my front side of my robot for this task. I'm going to dedicate my back side of my robot for the other task. It's going to make it a lot easier for you to build, and it's going to make it a lot easier for you to structure your weekly plan. Like, hey, this week I'm going to build this, next week I'm going to build that, and then the following week I'm going to have my programmer program the entire robot together. It's just make it a lot more structural instead of focusing on one task and then start adding more parts into your robot, because sooner or later you're going to run out of space. There's only the set amount of motors that you have. If I remember correctly, you cannot have more than 6 motors. So yeah, it's just make it a lot easier for you to task out all the things that you want to achieve for your robot beforehand, and then do it accordingly. So that's just my 2 cents on being proactive.
Yeah, honestly, could not agree more. Like that is huge what Kai just explained. It's so important to have those lists because I mean, in IQ you are working with middle school kids, elementary school kids, and they can put out great work, but they need a lot of guidance. So you definitely want to make sure that you're keeping that structure as Kai mentioned, so that you never find out that well here's 3 out of the 4 kids, where's the other person? What is he or she doing? And they're just sitting around looking at the wall, looking at the sky because they don't know what they're supposed to be doing. You can make your work more parallel that way too. You can say, okay, while person 1 works on the base, I want person 2 to work on the lift, and person 3, could you please start on some code so we can have something done when person 1 and person 2 is done. See, so instead of doing work like in line, spending an hour here, 2 hours there, 3 hours there, you did all the work in 3 hours instead of like 6. So you save yourself so much time by doing that. Does anyone have any questions before we go into our game breakdown? Today we're going to be doing Ringmaster. No questions? All righty. Here, I'm going to go ahead and stop the share and then change the share mode. All right, so I'm going to move this, go here. All right, so we're going to be doing Vex IQ Ringmaster. So if you remember from the first session, what we did was we watched the video, then we went through the rules, then we did a little Q&A and talking. We're going to be doing the same thing here today. So I've got the video queued up and we're going to go ahead and watch.
Funny convention I want you to see. It looks something like this.
Introducing the 2017-2018 game, Vex IQ Challenge Ringmaster. There are 3 ways to play Vex IQ Challenge Ringmaster. First, 2 teams will collaborate in 60-second teamwork challenge matches, working together to maximize their score. Both teams will receive the same points. Second, each team will have the opportunity to play driver skills challenge matches. In these matches, they have 60 seconds of driver-controlled time to score as many points as possible as an individual team. Lastly, each team will also have the opportunity to play programming skills challenge matches, in which they have 60 seconds of autonomous robot operation to score points. No drivers allowed. Vex IQ Challenge Ringmaster is played on a 4-foot by 8-foot field. Robots start on the field in predefined starting positions. The scoring objects used in Vex IQ Challenge Ringmaster are colored rings. There are a total of 60 rings on the field that are part of the game, including 15 that can be released from the bonus tray. The object of the game is to maximize your score with your alliance partner. Scoring rings in the floor goal are worth 1 point each. Scoring rings on posts are worth 5 points each. If a post has rings that are all the same color, that post is now uniform, and those rings are now worth 10 points each. Emptied starting pegs are worth 5 points each. And a released bonus tray is worth 20 points. For official robot requirements and game rules for Vex IQ Challenge Ringmaster, please see the Vex IQ Challenge Game Manual found at roboticseducation.org.
All right, so that was pretty interesting. We saw a lot about our game there. What are some things we noticed while we were doing this? You feel free to unmute your mic or go ahead and talk in the chat. Let's kind of break this down together. What are some things that we noticed when we watched that video? Notice we didn't notice anything. One sec. Okay, well, let me check the chat. Chat, there we go. Where's the chat? No, we didn't notice anything. All right, well, one sec. Let me pull up a quick notepad.
Wait, when you say anything, do you mean just anything?
Say anything that is related to the game itself, and anything that you find would be an advantage if you successfully do it.
Yeah, like what did you notice about the game that you think would be really interesting or something you could take advantage of?
I mean, obviously you need to get all of this. You obviously need to get things to pick up the rings, and you probably need a way to sort the rings into like 3 different like chambers or whatever you want to call it.
Okay, so from looking at the video, we can definitely see that. Here, let me add some new pages. Where is it? Nope, oh, that is the wrong button, oops. Where is it? Okay, so things we noticed that, you know, we might need, there are 3 colors. And so with those 3 colors, we might need to have a sorting mechanism or something to kind of store all these 3 colors. Okay, so we need to store 3 colors separately. Okay, so what about did anyone notice that, you know, they mentioned that there were 60 of these rings on the field? So that's quite a few rings. Is it even possible to score all those rings on them? Did you also notice the fact that, you know, all right, let me write this down. So if I can figure out how to, where is it? View select. No, not that. One second, I'm just trying to add another page here. One second, let me see if I can. Okay, there we go. And then insert. Give me one sec, share screen, and then share. Okay, there we go. So things we noticed, like we said, there are 60 rings. What you want to do now is that you've realized there's 60 rings. I don't even, do you think those are all scoreable? Like, is there enough space on these pegs to score all of that? Right? So one thing we can do is we can actually pull up the, where is it? The Vex Iq Field Manual, right? Because it'll have all the measurements of the field. So what we can notice is at the bottom here, it actually says how many rings you can score on each one. So what we noticed was, you know, we've got 60 rings and 20 of each color. So there's 20 red, we've got 20 blue, and we've got 20 green, right? And with each of those, we know that there are the pegs, and what do we say? We said we have our posts, we have our high post, which we have 1 of, 2 horizontals, and 4 lows. So we've got, you know, 1 large post, and that large post is, what does it say? So that large post can score a maximum of 20 rings, right? So that's an important thing to understand, is we can put a maximum of 20 on there. We've got what we have 1 floor goal, and you know, you can put as many as you can fit in there, so that doesn't really have like a limitation there. We've got our 4 low goals, and you know, those low goals, they're about 10 inches tall. We can score, it says a maximum of 6 rings in each of those. Then we've got, you know, 2 sets of horizontal goals. And on those horizontal goals, we can score 4 rings each, right? So, and those goals are going to be these ones over here. So, you know, 1, 2, 3, 4. So we have a total of 4 of those horizontal goals. And then we also have, what is it? Large, low sets. Yeah. So those are going to be kind of our goals there. So if you look at that, you know, 20 times 1, so that's 20. We would add in our 24 from the low goals, and because we can score 8 on each of the, or yeah, because we can score 8 total on the horizontal ones, we're looking at 16. If we add that up, you know, we got what, 20 plus 24 plus 16 will give us 20 plus 24 plus 16 will give us the 60 we need, right there. Double checking my math there, yeah. But so that means the only way we can max out on our points is if we score every single ring, and if we score them all on the kind of where they're all in the same color, right? So just keeping that kind of math in mind, let's see if we can go through the rules to see if we can find anything that would help us further our strategy here. So, we're seeing how, okay, so we've got 60 rings like we mentioned, 15 start in the bonus tray. Okay, so that's an important part. We don't have access to all those immediately. So we know that, let's do insert page after. So we know that out of those 60, 15 start on the bonus tray. So if we want to max out, we do need to use the bonus tray, right? So we've got our bonus tray there. We also see that 9 of them start on starting pegs. So these starting pegs at the bottom, we have to be able to do them. So, there's 3 pegs. And with 3 pegs, we've got a total of, what did it say, 9 rings on them? So about 3 per. 3 pegs, 3 per. They're also all the same color. So that might be an important thing to note is, in our strategy, if we want to pick up those pegs, we can make sure that we only pick up the same color as that, right? So they're not mixed up. It's not going to be a little hard for us to do. And so what you'll notice right now is we haven't even talked about any of the design, how we're going to physically build it. We're just talking about the math here because the math is what's going to define what we make. So we've got 3 pegs, 3 per peg, and they're all the same color. Ooh, same color. So, okay, that's a good important note to make. Additionally, let's see what else we have. So 1 floor goal. Yep. So these are all our kind of scoring options we've got. Let's see if we can scroll down. All right, so bonus tray. Yep, it's got that. So these definitions are what's going to kind of define what what the points are, what the goal zones are. So it's important that we recognize, any important definitions. So like, for example, the floor goal, it's the section of the floor bounded by the inner edges of the field perimeter and the back line, which runs the entire length of the field and passes under the support structure of the posts. So we know that the field goal or the floor goal is not just that little corner. It's actually, even if you can get a ring behind the physical goal, that still counts as the floor goal. High post. All right, so now we have some height. So this is good to know. And I'm going to go ahead and put, under our goals section for like the physical goals we can score in. So we've got 1 high. We've got our, we've got 1 high post. We've got 2 horizontals and I believe, 4 low posts, right? So our high is 24.5, so roughly like 25 inches. So 24 inches tall, and we can fit 20 rings. And then we've got, we've got a horizontal one. So how tall is our horizontal one? And one is at 8 inches and 14 inches. All right, so with our, I guess they're like 2 horizontals that are 8 inches. And there are 2 horizontals that are 14 inches. Now, each one of those can score 4 rings apiece. So we're looking at a total of 8 rings here and 8 rings here. All right. So what is something you would think would be important about those horizontal pegs? Does anyone have anything that think might be important about that?
You might need to make your robot grab the rings differently to get them on the horizontal pegs.
Yeah, that's exactly it, right? So horizontal pegs are oriented differently. So maybe you want to think about in your design, you might need a way to score that lets you score either both vertically and horizontally, or have 2 different mechanisms to do that, right? So, an important note might be, you might need a special scoring for this one. Special scoring mechanism for this one.
You might be able to just use a single motor and just have a way to flip it.
Have a way to flip it? Yeah, so, go ahead.
No, that's it, sorry.
Yeah, that's fine. So yeah, maybe you want to only have one mechanism, and you want to make sure your one mechanism can score both vertically and horizontally. So that is another thing. That's an important thing there. One thing I would note is, 8 and 14 inches are kind of a little far apart. So if you have a mechanism that you're making and you only want to use one mechanism, you want to make sure that that one mechanism can reach both those ranges and kind kind of deposit those rings at both those ranges, right? So you want to make sure that if you make some mechanism to score horizontally, it isn't just limited at scoring at the top one or the bottom one. And if you want to only use one mechanism to score all of them, then okay, you know that you've also got your 4 low goals, and those 4 low goals are only 10 inches tall, right? And those low goals will hold 6 rings per. So if we look at that, looking at the heights right there, to me, one thing that I noticed was that these goals are really different sizes, but they're all worth the same amount of points, right? So if I go to my ringmaster here and I go down, and this is a good example of what is scored, so make sure we're reading that as well. What is the definition of scored? So a ring is scored if it's not touching the robot and meets one of the following criterias. So contacting the floor, so that would be our floor goal, and any part of the post is through the volume. So we know that cases like all the way on the right do not count towards our score points, and cases on the left as well. Where is it? So here we go. So this is big. This is where our math's going to come in, our scoring points. So we know that, for our 4 low goals, it doesn't say that the goals are worth different amount of points, right? So all the work I would do to put something in the tall goal is worth the same amount of points as if I put something in the low goal. What does that tell you? Is anyone getting any ideas from that?
Want the easier one?
Yeah, right. So maybe you want to do the easier one. Maybe you just want to accept that, this tall one, although it's worth some points, it's worth the same amount of points as doing less work. So maybe it'd be more beneficial to do less work. Okay, how do we justify that idea? This is where the math will now come in, right? So what we know, we've got 60 rings, and to score those 60 rings, they're worth about 5 points a piece, but they can be worth about 10 points a piece if we score them individually, right? So if we do those rings and we score them individually, we're looking at about 60, 10, 600 points right there, right? So we're looking at 600 points. But to get those 600 points, remember, we also need to empty our, the tray on the side, and the 3 smaller pegs on the far side, right? So, and to do each one of those, if I remember correctly, emptying a starting peg is with 5 points. There are 3 of those starting pegs, right? And if you assume you're going to be getting all the rings, you're probably going to get those pegs. You have to get those pegs as well. So that means in doing those 600 points, you also get 15 points from emptying the pegs, and you also get 20 points from emptying the tray on the side. So all in all, we're looking at about 635 points. That is huge, right? And now we have a number. We know that, hey, maybe I want to chase that. Now, I think we mentioned earlier that tall goal is kind of really tall, right? It's a lot of work to get the same amount of points. So maybe I want to give that up. We now need to understand how many points am I really giving up by not putting anything in that tall goal. That's a potential of 20 rings that I'm not scoring, right? And so if we look at the ring count, 20 out of 60, that's a third. That is 33% of my rings that I'm not scoring, right? How does that affect my maximum score overall? All right, let's look at it. So what we can do is, and I'll insert a page after. Yeah, so if I look at my total scoring, if I don't score any of those rings there, right? So that's 20 rings I would not have scored. And if each one of those rings is worth 10 points, I'm losing 200 points out of that. So that's like, this is our max score. And let's say that we want to do a little bit less work. We're going to do minus 200. So we get 435 out of 635. If we just totally ignored that. 435, so 435 out of 635, that's 68% of all points, or 68.5% of all points, right? So we know that if we don't do that, we're not in like terrible shape. We're still getting a majority of the points, but we will be down about like 31%, 32%. So that's a good thing to keep in mind is that peg worth 32% of the points? Is it worth having to design something that can go all the way up to 24 inches? Those are kind of like design discussions you definitely want to be having, right? Additionally, so, okay, maybe we say that, we do justify that we don't want to put anything on that tall peg. Is it still possible to get a lot of points without doing that? And is it possible to even like, only have our uniform towers or uniform scoring goals or uniform scoring posts, by doing that? So what we would do is we'd go, okay, well, if we look at our posts here, right, what do we got? We taking that one post out, we've got 1, 2, 3, 4 posts available. So in terms of scoring, we've got 4 low posts. Each low post scores about, they said that each low post can score about 6 rings. So what we're looking at about 24 rings there. And then we've got our horizontal ones with 4 per like peg, but they're 2 pegs on each. So we're looking at about 16, right? So we've got 2 horizontals. Each horizontal each horizontal is like 8 if you count just the like vertical stack, not individually. So we're looking at 8 there. 8 times 2, 16. So that's another 16 right there, right? And so if we've done that, we're kind of out of other places to put things except for the full floor goal.
Isn't there the bonus, whatever?
There is the bonus tray, yes. So, okay, so with that in mind, let's see. Our bonus does hold 15 as well. So bonus holds 15 rings. So what this means for us is that if we do 20, 30, 40 rings, we can achieve our 68.5%, right? We can achieve that with only 40 rings if we do it right. So, and you'll probably get whatever change on top because you can push into the local. All right, now we have some semblance of like what our end goal is, right? We have some idea of what the points are going to look like at the end of the match. Now we're going to work on how do we get our points to look like that, right? So from looking at this game, what I can say is, all right, if I want to design something, I only want to design one scoring mechanism because I only have 6 motors and I might not have the motors to have 2 separate scoring mechanisms. So whatever one scoring mechanism I make needs to be able to score on the low posts, needs to be score on the high horizontal and the low horizontal, right? So that's something to keep in mind there. Does anyone have any ideas as to what do you see when you look at this game in terms of the orientation of those rings?
For motors displacements, you gotta understand. You gotta remember the fact that you always going to have to dedicate at least 2 motors for your drivetrain. So when you think about mechanism to score points or to grab or to lift your robot or to press on the rings or stuff like that, you actually only have 4 motors to dedicate to those. So for the lift mechanisms, you would want to dedicate 1 or maybe 2 motors for lifting the high post, the low post, the horizontal, all that stuff. Try to use the least amount of motors possible, because if you use all the motors you have and then you come up with another idea that needs another mechanism to use, unfortunately you won't be able to have that options, and it's going to be really hard for you to change your design later on.
Yeah, that's a great point, Kai. I didn't even think about that. So yeah, that's the type of insight Kai's got. But yeah, so does anyone have any ideas when they just look at it? Because to me, I see something like glaring at me.
Wait, is that rings like randomized?
That's a great question. The rings are not randomized. They'll always look like this at the start of the match, right?
Including the area over by like on the far left where it says 20.
Yeah. So those are going to be in the same orientation.
Okay.
Yeah. So on the note of, rings being randomized, we can see how, let me move this up. Yeah. So we can see how if we look at the side right by all those posts, what we notice is the green is always in the middle and the red and blue switches sides. Also, we've got 1, 2, 3, 4, 5, 6, 7 of those. So what that tells me is during the match, one robot could just sweep through those and they would have 7 rings. And because all the posts can only score a maximum of 6 rings on them, well, that tells me that my strategy should be I can start on one side, go up to the 6th row or the 6th line, and then kind of back up and score on the 3 posts that I haven't scored on yet, right? That means that I've got 1, I got the what is it, the isolation, or not, excuse me, not the isolation, but the uniform points. So each ring is now worth 10 points instead of 5. It tells me that I've scored that 3 times. So in that time that it took me to sweep that, I didn't even have to do a lot of moving around the field. I just had to drive kind of in a straight line. And I got 10 points multiplied by, 6 times 3, so 18. I got 180 points off that. That's a big amount of points out of our, what do we say? We were going for 435. If I get 180 points out of 435, I've done, let me see if I can do the math real quick. 180 out of 435. I've done 41% of all the points I plan on scoring just by doing that one move, right? So that's 41%, a little under 50. So, whatever time you have left, you want to spend scoring a little bit more points. So you can get to that 50%, right? Because your one robot might do 50% and your partner robot might do 50%. So that's a great move to be made. Does anyone else have any other ideas as to how they would approach? No?
You might be able to grab all the rings in the tray after you release it.
Okay, so that's a cool idea. So what if you had a little mechanism to just hold all the rings that fall out of the tray, right? So as they rain on, as they fall onto the field, you just have a big scoop there that you could pick them up with. So we'd have to check the size constraints and restrictions for that. But that is a good idea, right? You could maybe just take all of those and then turn it horizontal and maybe that's enough to put on the 20, right? So these are great ideas that you can definitely test out and do. One thing that I noticed is color sensing automation can be very efficient if the students design around it. Yeah, that's the end. Thank you, Chris. So you can automate that with color sensing, right? Vex IQ has the color sensor. So you already know that you have something to help you sort it if you get down to that, right? If you only want to have one intake mechanism, then boom, there you go. You can easily use your color sensor to sort. So that's really good. And no? Okay. So one thing that I noticed is these objects are hollow, right? So how do we even pick up hollow objects? Well, one thing you can do is you can look at previous years to kind of draw inspiration from. So when I think hollow objects, I immediately think VRC Skyrise, right? And so although it is a different game, it's still a mechanism that achieves the same thing. You don't need to just look at IQ mechanisms, right? Because you can get inspiration from the world around you. So one thing that I noticed was 2915A, one of the world champs from that year, definitely had a needle type design that would go through the hollow object and pick it up like that. So that's one way. Maybe we can make a mechanism to go through it. Another idea I can think of is 359 Poi Pounders. We're looking at a world finalist right here, and their mechanism, if we look at it from the video, we can see that their mechanism is kind of like a scoop, right? So it finds the empty space and picks it up from that empty space, kind of like holding it like a hook or an arm or something, right? So look at that. You see how it's picking up the cube and then going to place it on a post? We're looking at a very similar dynamic with that hollow object and such, right? So maybe you can draw inspiration from there, because this game did come, so the IQ game came after this. So maybe you could kind of look back and say, oh, maybe we could do something like that. So that is a huge opportunity. You can take advantage of getting inspiration from that, right? Additionally, we have a lot of videos that release early on. So one of the things you can do is formulate your strategy and look at some of the these good videos. I've picked out a few that I think would be a good example for you to look at, so you can get a feel for them. So for example, we've got this video here of a very early, we're talking August 29, so it's not too far. That's before the school year even begins for everyone over here. So we can watch this and kind of see how they chose to approach. So what you'll notice is, okay, they have 2 or 3 mechanisms to kind of hold everything. They've got one on the front side that is designed to do that. And look, they're doing a little sweep because they know that the greens are always in the middle and the reds and blues just switch sides. So they're pushing them to be the same orientation so they can use kind of a claw in the front. And on the back, they actually emptied the pegs with a specific mechanism for it. So they can score on one post, turn around and go back. And while you might be able to get some inspiration there, it took picking rings off those pegs seemed to be super easy with that, right? You could just kind of drive up and pull up. So that's an easy way to get 5, 10, 15 points and to boost your points for being uniform. So, that's one mechanism you can get an idea for just by doing that. Do we have any comments or ideas or things that we noticed off that?
Why does he look like Kai, but like really, really young?
I'm not sure.
The
That's
driver.
not.
It's
That's
not
not.
related. All right. All right. So another thing we can realize is, once we have this idea through, I watched some of the gameplay from our higher tier matches, and you'll kind of see like the ideas that we discussed kind of saw some existence, right? So what we're gonna do is we're gonna watch this video from our finals match. This is actually the world high score, and we're going to kind of break down what they're doing correctly here, right? So let's go ahead and full screen this. And so if we look at it, okay, we've got both our robots. They've kind of lined up. And okay, so we've got one immediately doing that move on the back that we mentioned earlier because they recognize that all the rings are the same kind of orientation, more or less. And someone else is now working on cleaning up the area, walking up towards those that bonus tray right there. So you see how they waited until they got all those things out of the middle before they approached the bonus tray. So that's a really big thing. What you'll also notice is, boom, we've got a mechanism. They've got internal sorting, so they can only have one intake mechanism, but still be able to, still be able to get that bonus for having uniform. They have a little collision here, so maybe a little bit of miscommunication, and then they go back, kind of break up to their sides, and start approaching. What you'll also notice is that this high tier play, they totally ignored that tall tower, right? That tall post. So one of the ideas we had was, that seems like a lot of work to get not too many points. Maybe you don't want it. And you can see that that was the same decision made by people at this world caliber. So that's a good prediction. That's a good thing we made. Okay, now we're here kind of working on getting those pegs off, and boom, time is out. So with all that combined, these guys were able to score about 417 points. 417 is just shy of what we mentioned here, right? With our 68.5% of the points. So they might have had that number in their head the entire time saying, hey, whatever it takes, we're going to try and score that 635. That is a definitive goal you now have that they are trying to achieve, right? So it's a really good thing we identified that, because from the beginning of the season, we could say, well, to be a good world champion or to be a really good team, we need this much points. That's a definitive goal. So there's that one. And another robot that I saw that I think like implemented it very well would be 2017. So that's 21549A. Let's see if we can go through it. So, going through their video. Got our rings, got our drive base. Okay. Very dramatic. Yes. Okay. So to see how they have a very similar mechanism for what we saw on that first video from the early season, right? That early season had just a passive kind of lift up. These guys have a motorized kind of hook, but it's the same idea of just having like a fork shape pull up. So that's very easy to design. Also very good to do. You'll notice that, they've got 3 pegs inside that kind of rotate. So what we'll notice is as soon as they, come on, somewhere here. Okay, so they're using the same scoring mechanism, right? 3 times, but they have like this, let me see if I can get a good, they have this like color sensor that they're using to kind of rotate it around whenever they want to score points or whenever they want to pick up the correct thing, right? So they're using one intake, just some flaps on chain. We see our rings are going to come in. And 1 goes in, 2 goes in, 3. They're all using the same intake, but they're internally sorted. So I know one of us brought up the idea of, internally sorting. That's a huge valid point, right? So we'll see, you can kind of see at the top here, there we go. So using the color sensor to sort, we now can score without losing the extra rings, but just using one mechanism. So we've saved motors, we've made it efficient. We don't have to have all these extra things around. So that's a great consideration because, as Kai mentioned, you have 6 motors, but only 4 of them you can really use. So that's one of the great, like a really well-engineered thing that I saw. What do you guys think about that?
Kind of cool.
I mean, yeah, it's kind of cool, right? So one thing you'll notice is everything we kind of mentioned, right? So we mentioned, ignoring the tall post. They ignore the tall post. We mentioned, keeping track of which ones you have internally using the color sensor to do that. They did exactly that. We saw that, they used one mechanism to score on posts of different sizes. So the horizontal ones as well as the vertical ones. So all these ideas that we're having, we did this in maybe about like 5 minutes. They spent the entire season doing. So can you use code for the driver control time? Yeah, so you can have a button that kind of helps you do that, right? So for example, they might just have a button that they push and it automatically sorts for them, or they might have a button they push and it automatically does the motion to score. So, that's a very, all these things that we thought of in this 1 hour session, they implemented. And that got them, whatever accolades they did, whether it be an excellence award, a championship, or whatever. So spending a little time does go a long way, right? So we have hit 5:04 now. That's kind of the end of the content I had prepared for you guys. So, thank you guys so much for coming out. If you haven't seen those previous videos from our last STEMinars, make sure you go online to check those out, because that'll actually give you a more accurate walkthrough of, how we approach a season. At this point, we're kind of good to do some Q&A. So, if you guys have any questions, I would love to hear them. I'd love to address them.
So Miss Carey has good questions on, can you use code for driver control? Yes, you totally can use coding for driver control. I actually suggest doing that because you can limit yourself to exactly 60 seconds. So you notice how each and every IQ game in competition, you have exactly 60 seconds to start the game and to end the game. With coding on driver control, you can actually control that. So at exactly 60 seconds, everything on your robot turns off, to prevent your students from, trying to score that 1 point and ended up using more time than they're allowed to and get disqualified for it. So yeah, to conclude that, totally suggest doing that.
Yeah. So is that, does anyone else have any other questions I can address?
What's some beginning advice you would have for newcomers to Vex IQ?
Yeah. So what is some beginning advice I'd have for newcomers for Vex IQ? So what I would say is, if you're new to Vex IQ, if that means if you don't have a team established yet, then I would recommend talking to your REC support manager or support person for your region. So for us, that would be Ben Mitchell in the Virginia area, and Jersey and Maryland, I think, as well. But for, if you already have a team formed and you're working on just, getting better, then I would definitely recommend that, you would use the resources we have already. So online, you could see that we've got a bunch of previous years game videos and game match play. Watching that game match play can give you a great example of how teams who have done really well have approached their designs. It can also give you a great idea of, what does a good mechanism look like. Additionally, just generally, I can recommend you would plan out your season, do a lot more slow planning and approaching. And maybe instead of being very dynamic and changing, your design every week, you spend a little bit more time thinking about it and being a little slower on that rise. But the previous STEMinar from last week or whatever that's on our YouTube does actually break down a recommended approach for how to break the game down step by step by step. And so that might be a good approach to kind of begin with. And then in this one, we did talk about how you would want to line your weeks up. Maybe saying 1 week for this and 2 weeks for that, definitely get you a good idea of your calendar and stuff.
Another suggestion for a team that just begin is to, if you have the opportunity to, and if your students agree to this, you can also specialize their task instead of just letting the students do whatever they want. So say you have a team of 4, you can dedicate one person as the programmer, 2 people as the drivers, and another person as the builder or the support of the team, or write what's that thing called? The notes.
Notebook.
Exactly, the notebook. You can specialize those tasks. It's, in my opinion, way more efficient than letting the students decide what they want to do. Of course, you can discuss it with them hey, if you want to drive, this is all you're going to do the entire season. So you're going to specialize in driving. But if you want to program, this is what you're going to do the entire season. You will not drive. You will not, do anything else except for only programming. In that case, say if I was the programmer, it just make me it makes my job a lot easier as a programmer to actually code the robot the way it's supposed to be, rather than having one person write this portion of code this day and then the next day come in and another person write this portion. It just make it a lot more messy. And for the driver, it's a big advantage for the driver to have the amount of time dedicated to them so they can practice driving instead of, splitting their time into programming and coding and stuff like that. So yeah, specializing is definitely one of the things that you can use, but just discuss it with your students first, because some teams don't really like doing that, and that's totally understandable.
Yeah. And that's a great point from Kai. What you'll notice is a lot of the teams at the upper echelons do have more kind of specialized tasks. But what I would recommend, in addition to trying specializing, would be making sure that all your students get the opportunity to at least get an appreciation for what they're doing, right? So if someone says that they're very set on specializing in programming, you might still want to get them the experience in building or driving or doing something else, just so they can branch out and see if they're interested at least, right, for the future. Yeah, great points there. Anyone else have any questions I can address? Definitely would love to make sure we're all on the same page, no one's confused, or any sort of things you have floating around I can help with. Well, I mean, I guess if we don't have any questions, that's fine. Thank you all for being a part of the session and being part of the STEMinar. Remember, we have future STEMinars coming up next week as well, where we're going to be breaking down more games. Yeah, paired programming, great idea. That's a good idea. That's how the industry works. But yeah, again, thank you for being here. This video will be uploaded to YouTube shortly, so just if you want to watch it again, we'll have that there. Hope you guys are all excited for the game reveal, and we can talk about it next week. So thank you guys.